Hello everyone, welcome to Not At All Discovery channel, and today we're going to talk about how physics is used to help fight the COVID-19. COVID-19, which is a respiratory disease spread by air. The virus carrying airborne droplets can remain in air or on a surface even after the ill person is no longer near. According to CDC, there are 320,000 deaths global-wide up to this point, and the number will continue to increase if scientists don't come out with a solution to deal with this situation. To defeat this COVID-19 or any disease, a vaccine is needed as it can prevent more people from being infected. Now, before we get into how scientists have been working on the vaccine for COVID-19, let's dive into how any vaccine works to help the immune system to fight a disease. A vaccine trains the immune system to recognize a pathogen and combat it. To do so, vaccine injects a certain molecule from the pathogen, which is called antigen, into the body to trigger the immune system to respond. Do you know that injection is only the same external feature of the antigen, but with a hollow inside, so it is safe for human body. Antigens exist on all viruses and bacteria, so finding the feature of an antigen of COVID-19 is the starting step of creating the vaccine. So how do we find the antigen of COVID-19? A method called cryo-electron microscopy, often known as cryo-EM, is applied during the process. Electron microscopy works by generating a single beam of electron focusing by electromagnetic lenses and fire it at a sample. The electrons then interact with the nanoscale component. This method allows us to visualize samples in detail, much better than an optical microscope, because the electrons have shorter wavelengths than protons. Therefore, electron microscopy helps us to observe more details in the cellular and molecular structure. Cryo, meaning in extremely low temperature, is applied during the EM process by freezing the sample, usually using liquid nitrogen. By doing so, it reserves the sample at its original states and prevents any damage from the microscope, which is at room temperature, like dehydrating, coloring, or destroying the structure of the virus. By February 15th, a team of researchers from UT Austin and National Institution of Health come out with the first three-dimensional structure of COVID-19 spike protein, which is also known as S protein, and is now published in Science. With the nano sequence shared by Chinese researchers, they managed to prepare a purified sample of the spike protein and to determine its structure using the cryo-EM in less than 2 weeks. Scientists are now working on producing the vaccine of COVID-19 based on these samples. So here are my sources, and this is all for today. Thank you for watching. Best wishes to you all, and I'll see you in the next one. Bye bye.